This is the semester 1 review. We're going to talk about problems 1 to 14. Problem 1 says describe the transformation of each graph. So in the first equation, y equals negative 2, x minus 3 squared plus 1, this is a quadratic equation in something called vertex form. And the nice thing about vertex form is that the vertex, which is at h comma k, tells you the direction that the graph of the parent function, and the parent function is y equals x squared, has been transformed. K always moves the graph up or down. So in this case, plus 1 means the graph has gone up 1. H always moves the graph left or right. If you think about setting what's inside the parentheses equal to 0 and then solving, 3 would be to the right of 0, so we say that the graph has moved right 3. The negative in front makes the graph reflect over the x-axis. The negative is independent of any other number that's in front of the parentheses. Now let's talk about the number in front of the parentheses. When the number in front of the parentheses is greater than 1, we say the graph has been stretched. And when it's between 0 and 1, we say the graph has been compressed. So in this case, the graph has been stretched by a factor of 2. In our case, stretching means that it made the graph narrower. As long as you know what the parent function is, and it's usually very easy to know what the parent function is, we can determine the transformations. And it doesn't matter the degree of the polynomial. It works the same way every time. The number outside the parentheses is the number that moves the graph up or down. So in this case, the graph has gone down 3. Inside the parentheses is what moves the graph left or right. Remember, if you set this equal to 0 and then solve, that'll tell you if it's left or right of 0. Well, negative 2 is to the left of 0, so it moved left 2. The negative in front of the parentheses always means reflect over x-axis. If you're having trouble with this, remember that another method for determining how the graph moved is if you can determine the parent function, graph the parent function and the new function, and you'll be able to figure out how it has been transformed. In C, y is equal to x plus 1 squared minus 3. All that's happened is the graph has moved down 3, and this moves the graph left 1. And those are the only transformations. In problem 2, we want to find the equation of the axis of symmetry and the vertex of the function. We also want to determine the y-intercept of the graph of the equation. The reason those 3 pieces of information are really useful is because if you don't have a graphing calculator, you can draw a relatively accurate sketch. I'm going to start with the y-intercept because when an equation is written in standard form, y equals ax squared plus bx plus c, c is the y-intercept. So in this case, the y-intercept is 0, negative 5. Remember, the y-intercept is where x is equal to 0. The axis of symmetry is always found using the equation x is equal to negative b over 2a. Be careful for double negatives. So negative, and then in parentheses I'm going to put b is 2, over 2 times a in this case is negative 1. So negative 2 over negative 2 is positive 1. So the axis of symmetry is the vertical line x equals 1. The axis of symmetry is also the x-coordinate of the vertex. So now in order to find the y-coordinate of the vertex, all I have to do is plug 1 back into the original equation. So it's negative 1 squared plus 2 times 1 minus 5, which is going to be negative 1 plus 2 minus 5, which is negative 4. So the vertex is the ordered pair 1, negative 4. In problem B, f of x is equal to negative 2x squared minus 8x plus 3. I'm going to start with the y-intercept, which is at the ordered pair 0, 3. Now let's find the axis of symmetry. The axis of symmetry, negative b over 2a. So it's positive 8 over negative 4, which is negative 2. And again, the axis of symmetry is a vertical line. To find the vertex, I need to find y, so I plug negative 2 back into the original equation. Let's see, this is going to be negative 8 plus 16 plus 3, which is 11. So the vertex is at negative 2, 11. Problem C, f of x is equal to 4x squared minus 2x plus 1. The y-intercept is at 0, 1. The axis of symmetry is that x equals negative b over 2a, which is positive 4 over 8, which is 1/2. And to find the vertex, we're going to plug 1/2 back into the original equation to find y. So this is going to be 4 times a fourth is 1, minus 2 times a half is 1, plus 1, which is equal to 1. So the vertex is at 1/2, 1. I'm doing all the math here, by the way. You would probably just do this on the graphing calculator. Please remember, when you utilize the graphing calculator to assist you with mathematical calculations, please use parentheses, even if you think you don't need them. Problem number 3 says, an archer's arrow follows a parabolic path. The path of the arrow can be described by the equation y equals negative 0.005x squared plus 2x plus 5. Describe the meaning of the y-intercept of the graph of the equation. The y-intercept is 5. That means if I were to graph this, the graph starts 1, 2, 3, 4, 5. And I want you to notice that the leading coefficient is negative, which means it's a parabola that opens down. So the path of the parabola probably looks like this. But this is a real-world problem about an archer and an arrow, which means that the y-intercept in this case represents the initial height of the arrow. The guy was either 5 feet tall or he was holding the bow and arrow at 5 feet above the ground. So the y-intercept represents the initial height of the arrow. Problem 9. The New River Gorge Bridge in West Virginia is the world's largest steel singles arch bridge. You can model the arch with the function y is equal to negative 0.0005x squared plus 0.85x, where x and y are in feet, and the origin represents the base, the left base of the supports. Approximately how high above the river is the arch? How long is the section of bridge above the arch? Since they tell us that the arch is 516 feet above the river, what we're going to do is we're going to find the vertex of that parabola, which is the maximum of the parabola, and we're going to add 516 to it. Because when we find the vertex of the parabola, we're really only finding this distance here in blue. Well, how are we going to find it? X is equal to negative b over 2a, which we're going to find out is 850. Now that means this distance here is 850. So the second question, which is how long is the section of bridge above the arch? Notice in the picture it makes a rectangle. So if it's a parabola, parabolas are symmetric, so each of these lengths is 850. So 850 plus 850 is 1,700 feet. That's the length of the section of bridge above the arch. Now let's continue finding out how high above the river the road is. So we're going to plug in 850 back for X. And we're going to find out that it's equal to 361.25. But the thing is, that's not the height above the river. That's the height along a horizontal line connecting the base of each side of the arch. So we have to add 516 to that in order to find out exactly how high above the river the road is. And it turns out it is 877.25 feet. Oops, sorry. Number 5, the Jiaozhou Bridge in China is the oldest known arch bridge dating to AD 605. You can model the support arch with the function f of x is equal to negative 0.0011x squared plus 0.13x, where x and y are measured in feet. Approximately how long is the section of the bridge above the arch? Just like in the last problem, here's the arch. They want to know the section of the bridge above it. So really what they're doing is they're creating a rectangle. So this length up here will be the same as the length between the bases of the arch. To determine what that is, we need to use the axis of symmetry formula to find this length here. The length on the other side will be the same because parabolas are symmetric, so the answer we get for x will just be multiplied by 2. So x is equal to negative 0.13 over 2 times negative 0.0011, and that's going to equal 59.09, because when we get a decimal, we usually round to the nearest hundredth. And now I'm going to multiply that number by 2, because this is 59.09. This must also be 59.09. So all I have to do is multiply that answer by 2, and I find out it's 118.18 feet. In problem 6, for each graph of each function represented below, we want to determine the domain and range of the function. All right, here's the deal. With quadratics, unless you are dealing with a real-world application problem, the domain is all real numbers, always and forever. The range, however, has to do with where the maximum or minimum of the graph is. I want you to notice that the minimum is down here at negative 10, and the rest of the graph is above it. In mathematics, above means greater. We're actually going to use greater than or equal to negative 10. The range is y is greater than or equal to negative 10 because the rest of the graph is above that horizontal line. B is negative 3x squared minus 4x plus 6. Again, for all of these problems that are quadratics and not real-world application problems, the domain is all real numbers. The range, because this graph has a maximum, the range is going to be y is less than or equal to 7.3 repeating. Now, I used the graphing calculator app to find where the maximum was at, and the y value tells you the maximum. But you don't have to do it this way. You can algebraically find the value for the maximum or minimum by using the axis of symmetry, negative b over 2a, in which case it would be 4 over negative 6, which is negative 2/3. Negative 2/3 is your negative 0.667. They rounded it off. And then to find y, you would plug that back into your original equation, and you would find out it's 7 1/3, or if you want to tell me that it's 22 over 3, or if you want to tell me it's 7.3 repeating, any of those is a good option. Remember, this is a multiple choice test, so if the answer is given to you as a fraction, you can just turn the fraction into a decimal to make sure you did the problem correctly. In problem C, x squared plus 2x plus 3. The domain is all real numbers. The range, because it has a minimum, is y is greater than or equal to. In this case, it's 2. And again, remember, you can find this algebraically as well, or you can find it using the minimum or maximum function on your graphing calculator. In problem D, here's the graph of negative 2x squared plus 2x minus 5. You'll notice where the maximum is at. So in this case, the domain is my all real numbers. This is another notation for all real numbers. It looks like an R with an extra leg. And the range is going to be y is less than or equal to the y coordinate of the maximum. And again, you could have found this algebraically by finding the axis of symmetry. And then plugging the axis of symmetry back in to the original equation to find y. And you would have gotten the exact same answer. It just depends on which way you would like to do it and if you're comfortable with the graphing calculator or not. Number 7, a model for a company's revenue from selling a software package is R equals negative 2.5 p squared plus 500 p, where p is the price in dollars of the software. What price will maximize revenue? Find the maximum revenue. This is a real-world application problem asking you to do something that we have already done. It is asking you to find the axis of symmetry. It's just that instead of the input being x, it's p. So negative b over 2a is 100. So that's the price that maximizes the revenue, because remember, p is price. And then the maximum revenue you get by plugging 100 back in for p. And you find out that the maximum revenue is $25,000. Number 8 is the exact same type of problem. The expression p of x is equal to 2,500 minus 2x squared describes the profit of a company that customizes bulldozers when it customizes x bulldozers in a month. How many bulldozers per month must the company customize to make the maximum possible profit? What is the maximum profit? Now, the order in which the polynomial is written does not change where A, B, and C are. A is always in front of the square term. B is always in front of the linear term. Students get confused and they want it always to be in order A, B, C, and it's not. Just keep that in mind. So in order to find out how many bulldozers we need to make, we're making axis of symmetry. Again, x is equal to negative, in this case, b is 2,500, over 2a is negative 2, so it's negative 2,500 over negative 4, which is 625. So that's the maximum number of bulldozers I need to make. Now I want to know what my maximum profit's going to be. Well, my maximum profit is what I get when I plug in 625 for x. and it's going to be $781,250. In problem 9, I want to find the x-coordinate of the vertex of each equation. That means I'm looking for the axis of symmetry each time. If you want to use your graphing calculator to find the maximum or minimum, just remember that it's the x value of the maximum or minimum that you are finding. But if I do it algebraically, in the first problem, I'm going to get positive 4 over 2, which is 2. Next, I'm going to get negative b over 2a, which is negative 2 over 2, which is negative 1. And in problem C, I'm going to get negative b over 2a. Negative 8 over negative 4 is 2. In problem 10, we want to write an equation of a transformed graph of the parent function y equals x squared. That is a vertical stretch by a factor of 2, a vertical translation 5 units down, and a horizontal translation 3 units to the left. The horizontal translation is always written in the parentheses, and to the left will be plus. So this is the polynomial that has been transformed by a vertical stretch by a factor of 2, 5 units down, and 3 units to the left. So in B, we're going to do the same thing. A reflection across the x-axis. A vertical translation 6 units up. And a horizontal translation 4 units to the right. 4 units to the right will be x minus 4. So there is our quadratic. By the way, there aren't 3 separate answers. I'm just showing you how I incorporate each description into the equation, and I'm boxing the final answer. All right, in C, a reflection across the x-axis. A vertical translation 5 units down. A horizontal translation 2 units to the left. 2 units to the left will be plus 2. Remember to be careful in these application problems about what your input and output is. In number 11, Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time can be modeled by the function h of x is equal to negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. How long did it take Jason to reach his maximum height? First of all, the question says how long, which means they're looking for time, but they want to find at what time he hit his maximum height, which means we're looking for the axis of symmetry. Again, yes. Except instead of x, it's t, and it's still negative b over 2a, so it's negative 16 over 2 times negative 16, so it's negative 16 over negative 32, which is 1/2, or 0.5. So 1/2 a second, 0.5 seconds. Notice that these equations are all very similar on this page. That's because we did a whole worksheet on this, where this is this equation. Negative 16 is our acceleration due to gravity. Since we're going towards the Earth, the acceleration due to gravity is negative. And in mathematics, instead of using 9.81 meters per second squared, like we do in physics, we use 16 feet per second squared. And so that's where the 16 comes from. The number in front of t is the initial velocity, and the constant is your initial height. So notice in this problem, the initial height is 0. If a toy rocket is launched vertically upward from the ground level, that's why our initial height is 0, with an initial velocity of 128 feet, look, there it is. Then its height after t seconds is given by the equation negative 16t squared plus 128t if air resistance is neglected. How long will it take the rocket to hit its maximum height? Again, ask yourself what they're asking to find. They want to find the time to hit the maximum. That's the axis of symmetry. Negative b over 2a. And it turns out it's going to take 4 seconds. A ball is thrown into the air. Its height above the ground at any given time after the ball is thrown can be modeled by the quadratic function negative 16t squared plus 16t plus 32. Find the time it takes the ball to reach its highest point. T is equal to negative b over 2a. And it is again a half a second. In problem 14, it says a ball was thrown into the air with an initial velocity of 72 feet per second. The height of the ball after t seconds is represented by the equation h equals 72t minus 16t squared. The graph of the function is shown right here on the screen. What is the reasonable domain for this particular function? Remember that domain is in reference to the x values. So, since the x-axis is in time, a reasonable domain is anywhere from 0 until the ball comes back down at apparently 4.5 seconds. So we would say the domain is between 0 and 4.5. Or we may have used t instead of x. They didn't ask for the range, but if they had, the range would have been the y values from 0 to, we'll say that's like 82 feet. So if they had asked for the range, it would have been from 0 to approximately 82.